Hello everyone, Happy New Year. Welcome to the first vlog of 2022. This vlog is a continuation of the Computer Vision series that I started a month back. In my previous vlog, I covered a little bit of nuisances of object detection mechanism. I give you a brief overview of how this mechanism comprised of two different techniques called image classification and object localization. You also got an idea of a YOLO model architecture, which is a very widely popular model for computer vision exercise in my previous vlog. If you missed that vlog, I'll definitely recommend you to go back to my channel, watch that vlog before you proceed further with this one. So now, in today's vlog, I'll give you a code walkthrough of how you can perform your first YOLO model exercise using Python programming language. Now, before proceed further, don't forget to like and subscribe to my channel because more contents on computer vision are forthcoming. Now let's take a look at this video, which I built like a year back when I first worked on the YOLO model project. So in this video, you will see that there is an autonomous car detecting all the surrounding cars while it's driving on the street. So this particular object detection is being performed in real time. As you can see that most of the cars are actually within like a few feet vicinity of that autonomous car right now. And it also helps the car to detect those moving objects and avoid them. It also detecting the traffic signals at the intersection, because it's very important for a car to detect the traffic lights accurately to avoid any sort of accidents. Okay, so now you already watched the video. So let's see how we can actually perform similar sort of exercise using your Python programming language. So let's get to the coding section. So in the coding section, I'll give you just like a brief overview of how you can develop your first YOLO model program using the pre-trained model, like using the transfer learning approach. So for this exercise, I used a course, and this exercise was a part of like a course assignment offered by deeplearning.ai. So they provided the dataset, and the dataset actually came from this company, drive.ai. So they took all the pictures, they took all the images by their autonomous car, and they then loaded into that course library. And when we are actually writing this YOLO the program, we invoke those images and process those images through YOLO model, and that YOLO model provide that accurate detection of those objects in real time. So now, first of all, let's dive into some of the basic part before you write the model, any functions. Like for example, before you get into the YOLO model, before you write any function, you need to invoke some of the important packages, such as like NumPy, Pandas, TensorFlow, and Keras are very important libraries, machine learning libraries for object detection, because they have some inbuilt function that you need to load the model to define some of the functions in the later stage. Also for this assignment, we used an utils file, and that utils file comprised of some of the predefined function that we use to define some of the bounding boxes, drop some of the boxes, and also get the accurate scaling functions and reading the the classes, and also pre-process some of the images beforehand. So that utils, so you can always follow that utils package, or write your own utils package to perform those similar sort of action functions. I already shared the link of this Jupyter notebook in the video caption section. So I'll definitely recommend you to check that. This code is already uploaded to my GitHub profile. And if you have any questions, please feel free to share that in the comment section of the video. So now let's go to the next section of this Jupyter notebook. So, but let's do a recap of how this YOLO model actually works. So in the YOLO model, we'll take the images, we'll take a batch of images as an input, and it will provide output as a list of bounding boxes along with the recognized classes. So those bounding boxes will give you the lookup, the location of the object in the form of like a x coordinate, y coordinate, height and width, and also give you a probability score of that particular class which belongs to that object. Okay, like for example, here what the YOLO model will do, YOLO model will define a bounding box surrounding this over this truck, and it will also give you a probability score of maybe 80 or 90% accurate identification of this object as truck. Okay, because it's possible that in some cases the model mistaken this object as car, but if you have the class label truck in your YOLO model, then it should be able to define this particular object as a truck instead of car. So when you perform your YOLO model, it's very important that the encoding architecture, and the encoding architecture is nothing but it's a anchor box. So in our exercise, we have 5 anchor boxes that we predefined in anchor file. So these anchor boxes is actually consider it like each of the 19 by 19 cells, which encodes information about 5 boxes. And these anchor boxes is usually defined by their width and height. And most of the cases when you process your anchor boxes through a neural network, it flattens the shape. So flatten the shape in such a way that the final output of that CNN would be 19 by 19 by 425. Okay. And once you have this, once you actually encoded the output of the convolutional neural network in such a way, the next thing would be to determine the class probabilities. And for the class probabilities, what it does that if we have 80 different classes in your model, so your model will perform an element-wise product for each class. And after you get that 80 different probability scores, then the model will determine the class of the object based on the highest probability score. Okay, so say suppose there is an object, and an object has like probability score of 40 for tree, 35 for human being, 50 for a car, and 60 for truck. So in that case, that model will actually determine that that object belongs to a truck, because the truck probability score is highest among other 80 classes. So that's how the probability score is very crucial to determine the image, the classification of for the image classification. So now let's go to the next section to see how we usually transform this logical part into code. Okay, so in the first section, we define a function called YOLO_filter_boxes, and we share some of the arguments as input, such as boxes, like anchor boxes. We share information of the box confidence, because the confidence interval is very important to determine the accurate class of the object. We also provide the box class probabilities, because we need to get the probabilities of each class, so we can perform that element-wise product, which I mentioned a few seconds back, and then determine the accurate class of the object. So once we first define this function, and then the next step would be to perform non-max separation. So now, what is non-max separation? So if you see that in the picture on the left has too many like bounding boxes. Okay, so now it'll be difficult for the model to accurately locate the object if you have too many bounding boxes. So we need to suppress the bounding boxes into one. Okay, So ideally, we use this non-max separation technique to come up with the only one single, come up with a single bounding box for each object, and we perform that non-max separation mechanism using a method called intersection over union. So what we do is we perform an intersection of two bounding boxes, means we come up with the inter area of two bounding boxes, and then divided that inter area by the union of those two boxes. So this is actually the intersection over union mechanism. And how you actually transform that into code? Very simple. We pass two box values as input. We define the x coordinate, y coordinate of those two boxes. And based on the x and y coordinates, we calculate the inter area and union area as well. And then we just perform the simple mathematical calculation to compute the IU. So once we get through this non-max separation part, the next thing would be to load the model. Okay, so before you load the model, we also have to write one more function just to make sure that we have a function, some method ready which can evaluate the YOLO model. So that is evaluation section is covered in this YOLO_eval, where we are getting that YOLO outputs as an input, means all the outputs you're getting from those encoded bounding boxes. So those encoded part will be feed into the YOLO model as input. We have the image shapes and everything. And once we calculate the evaluation part, then the next step is to just provide the scores, boxes, and classes. So during this YOLO eval function, you would actually see that this function is comprised of YOLO filter boxes and YOLO non-max separation. So that means whatever the mechanism, the pre-processing mechanism we have to perform before we feed the image into YOLO model have been done over here. Okay, so once you get done with that stage, then the next stage is to use that those data for further model processing purpose. So now we get done with all the function part. The next thing is to load the class file and the model. And the class file is very important, because if you don't have the proper class file with the accurate class information, then your model won't be able to identify any of those objects. So always make sure that the model, the pre-trained model you're using for your exercise should have at least minimum classes, so it could identify this object. So for that purpose, we loaded this cocoa_classes text file. And I mentioned that before, that we also have an YOLO and anchors file, and that anchors file will predefine the number of anchor boxes we would use for this YOLO model exercise. So we have to load those two text files, so in order to predefine the number of classes and number of anchor boxes. The next thing is that load the model. So once you load the model, so now we have the model information, we have the classes information, we have the anchor boxes information. So we can definitely feed those information as an argument to the YOLO_eval function. So once we perform that part, the next thing is to predict. So to perform the prediction, so the few things we need to understand that how we can actually perform the prediction. So for that, we are going to use that predefined function YOLO_eval. The YOLO_eval will get all the image information as an input, and it also has the information about the image size and everything. It will provide output in the form of probability score, the box, and the classes. So it will basically give you an output of in a form of a box, and the box will actually have the information of the class followed by the probability score. Like if you remember the video I showed you, let's take a look at that one more time. So if you see that all this output is nothing but a bounding box, the object class, and the corresponding probability score. Okay, so that section is over here. So this is the output, main output we're getting from the model. So every time you're actually, every time you will see an output, autonomous car is detecting something on the street. It's basically detecting that object based on their probability score, the bounding box, and the class. So now this is actually one of the main, one of the like a test I performed during the exercise is like I kind of just loaded an image comprised of so many different cards, different cards and like bus. So the model was able to accurately identify the class of the objects. Like it's basically able to identify the classes. It also able to identify a bus in the picture and also it's providing the corresponding probability score of that object. Like this model was able to identify the class accurately. Like so the probability score of this object falls in that car within that car class is 89%. So model is basically predicting that the model is like accurate that and accurately predicting that this class is 89% of belongs to the car class. So that's kind of like in a nutshell. It's like the main idea of the YOLO model is to perform the exercise, get the boxes and classes and the scores as an output. And when you are running the model, or when you're running a when processing an image or video through an YOLO model, it always try to accurately provide those information. So the summary is input image 608, 6083. The input image goes to a CNN, resulting in a 1919 585 dimensional output. So that's like an encoded part. So when you're done with the encoding, you get the dimensional output. So then you flatten that because, as you know, in the convolutional neural network, you actually have to flatten a layer so you can pass it to the next, the final output linear layer. So once you flatten the last two dimension, then it becomes 19 by 19 by 425. And here you might be wondering that we have 80 classes, and where we have 5 is because for each class we have a probability score, their X and Y coordinate, height and weight. Okay, so and other 5 is nothing but the anchor number of anchor boxes. So once we flatten the dimension, then we get the final output in the form of bounding box, probability score, and the class name. So always remember that this YOLO is still a state-of-the-art object detection model. Still a lot of research going on to develop the model, to upgrade the model. So it's also very important to understand that how the class information play a crucial role to accurately determine an object or identify an object. Because so suppose for this particular exercise, I have 80 different classes. But in future, if I want to incorporate more class information, then I have to basically update that coco underscore classes file. I also have to make sure that the YOLO model will be trained using those additional classes. If you do not pre-train your model with the additional class information, then your model won't be able to identify the object, so regardless of whether you have the information in the class file or not. So it's very important to identify the accurate classes and provide that information in the class file, so your model will be able to pick up those information during model training phase. This exercise is less time consuming because we're not spending any time to train the model. Rather, we are using pre-trained model as part of like a transfer learning approach. But I'll definitely recommend you to use your expertise, use your judgment to add more classes and train a YOLO model from the scratch. You already know this, and now you know the main architecture of the YOLO model. So this is basically the summary of that YOLO model. So you can go back to my GitHub account. I already pasted this. I already shared the link of this Jupyter notebook in the video caption. I'll recommend you to go back to the Jupyter notebook and just check the summary of the model and just see that how many different convolutional layers, max pool and the linear layer contains in YOLO model. Because if you see the way the model summary works, then you can always add more layers to it to make this model more robust, or you can feed more additional classes to the model during model training phase. It will be definitely a very time consuming. You might need a GPU processor or like a high computing power in order to train such an extensive model, but I'll definitely recommend you to give it a shot to see how you can actually train a YOLO model from the scratch with additional classes. So that's all for now. Hope you enjoyed this vlog. I'll definitely recommend you to go back to this, check the Jupyter notebook that I shared in the video caption. Also, there are some more YOLO model YOLO model exercise going on in other elsewhere. So you might find more articles related to YOLO model, but this is a very basic implementation of YOLO model using Python. And most of the cases, we just pretend the YOLO model. We usually don't train it from the scratch, but maybe you can improve this model in future. Maybe so give it a shot and see if you can add more parameters to the model, which will accurately identify the objects from surrounding objects for an autonomous car. So I shared, so yes, don't forget to look at the video caption where I shared the Jupyter notebook link, and also watch the video, and maybe you can come up with a better video similar to what I did before. But as you can see that this model still need to be improved a lot, because there are so many other surrounding objects it is not able to identify properly. So there are a lot of scope of improvement. So please take a look at the Jupyter notebook and let me know if you get a chance to improve the model, or if you'll be able to add more layers which may improve this object detection exercise program better in future. I'll be happy to discuss with you further this. So that's all for today. I hope you enjoyed this video, and I'll see you next time with another vlog related to computer vision. Thank you. Have a nice day ahead. Bye.